Unit 21 Biomolecules Blueprint Part 1 2 1 mark questions, Part 4 1 5 mark questions. Under the biomolecules we are going to see carbohydrates. The very first discussion starts with carbohydrates. Carbohydrates, as the name implicates, it is having carbon, hydrogen and oxygen. This can be classified into two groups, sugar and non-sugar. Under the sugar, the combination of 6 carbon is called as monosaccharide. For example, C6H12O6. This is the 6 carbon combination. It is called monosaccharide. Of course, this is the formula for glucose and fructose. Glucose and fructose have the same formula, C6H12O6. They are called monosaccharides. Glucose has aldehyde group. And fructose has ketone group. So glucose and fructose are having same molecular formula but different structural formula. Glucose is having one primary alcoholic group, 3, 4, 5, sixth one is aldehyde, and all the remaining are secondary alcoholic group. So glucose, it is glucose. Glucose has one aldehyde group and one primary alcoholic group and 4 secondary alcoholic group. So it's a polyhydric group. Polyalcohols, we can call it as glucose. Fructose begins with primary alcohol and having keto group, and the remaining secondary alcoholic group. So fructose totally 6 carbons are there, out of which in glucose you are having one aldehyde, one primary alcohol and 4 secondary alcoholic group. This is in the case of glucose. In the case of fructose, 2 primary alcoholic groups are there. CH2OH is called primary and 3 secondary alcoholic groups are there and 1 keto group. These two have the same formula, C6H12O6, but having the different structural formula. That's why they are called functional isomers. They are differing only by the functional group. Glucose has aldehyde group, fructose has keto group. So they are differing by functional group. That's why they are called functional isomers. Here, the glucose has aldehyde, so it is also called aldose. Since glucose has aldehyde group, it is also called aldose. And fructose has keto group, so it is also called ketose. So it is monosaccharide. Suppose 6 into 2, 12 carbon involves. 12 carbon involves. It is called disaccharide. It's a disaccharide. Disaccharide upon hydrolysis gives monosaccharides. Say, example is sucrose. The ordinary sugar, what we are eating, is the sucrose. It's a disaccharide having sweet taste. When it is hydrolyzed, you are getting glucose and fructose. So sucrose is hydrolyzed to glucose and fructose. It is called disaccharide. So 6 carbon combination is called monosaccharide. 6 into 2, 12 carbon combination is called disaccharide. 6 into 3, 18 carbon combination is also there. It is called trisaccharide. Formula is C18 H22 32 O16. It is called raffinose. So the raffinose is the trisaccharide. Upon hydrolysis, it forms 3 monosaccharides. 3 monosaccharides. That is glucose, of course fructose, then galactose, glucose, fructose and galactose are functional isomers. So, sucrose disaccharide upon hydrolysis, forms 2 monosaccharides. The trisaccharide raffinose upon hydrolysis forms 3 monosaccharides. Then, when the 6 carbon unit has been millions of million times repeated, likewise C6H12O6 has been repeated by O5 has been repeated by n times, it is called starch. That is polysaccharide. When it has been hydrolyzed by n number of water in the presence of H plus, you are getting n molecules of glucose. N molecules of glucose. It is called non-sugars. All the polysaccharides are called non-sugars. In the polysaccharide, monosaccharides are combined by oxygen bridges. The oxygen bridges are called glycosidic linkages. Starch, cellulose are the examples of polysaccharide. In the normal stage, in nature, how the carbohydrate has been. You could have seen cotton plant. Initially, a small bud, cotton bud could have been created. It is having baby pink green, baby green color. The bud may have very sweet taste because initially it is in monosaccharide. Then it is converted into disaccharide. Once again, it is having the taste, sweet taste. And finally, all the petals of cotton could have been opened and white color cotton emanated out. It's a polysaccharide, has no taste. So initially it is in monosaccharide form, then it is converted into disaccharide, then it had the sweet taste. But once it becomes the polysaccharide, it has no taste. The structure of glucose, the elucidation of structure of glucose is a very important 5-mark question in this chapter. Suppose you imagine Structure of glucose, we are not aware of structure of glucose. We don't know the structure of glucose. Then how to find this? The very first step is, we are doing elemental analysis. Elemental analysis means we have to find what type of element is there. Suppose glucose has been taken, the white color powder is given in your hand. You have to find its formula and structure. The very first step is elemental analysis. You are doing test for each element, what element present there. And you are finding that it is having carbon, and it is having hydrogen, and it is having oxygen. It is called elemental analysis. What element present in one compound is called qualitative analysis. Then you are measuring how much carbon, how much hydrogen, and how much oxygen. It is called quantitative analysis. There are two analyses, qualitative, another one is quantitative. Of course, by elemental analysis, we are finding that the formula of glucose is C6H12O6. Understood? So by the elemental analysis, we found the molecular formula, and we found that it is having 6 carbon, 12 hydrogen, and 1 oxygen. Now, this glucose is allowed to reduce in the presence of hydrogen iodide and phosphorus. It is undergoing reduction.